All right, in today's video reference, we're going to switch gears and start to look at exponential decay. But now, before we do that, let's kind of remind ourselves what growth looked like. So we go over here where it says your notes. Can someone tell me what's the format for exponential growth or the exponential functions? It's y equals a times b raised to a power. And just remind me, which one is your y-intercept? Yeah, it's your a term. So with growth functions, the line was a smooth curve, and basically as x increased, it got bigger and bigger, bigger and bigger, bigger exponentially. So now, what do you think is going to happen with exponential decay? Yeah, it's going to look the other way, where it's going to get smaller and smaller with a smooth curve as x, never actually touching that ending, but as x increases, it's going to get smaller and smaller and smaller. So the function, it hasn't changed in format, y equals a times b dx. So something's going to change about this that's going to make the curve change from here, which is growth. Now the curve's going to decay. So if you look up here, if you look at this example, the first one, you can probably already guess is what's going to make the decay happen. So the difference here is we have a fraction. 1/3 is our growth rate, so we're going to multiply by 1/3. Someone tell me, as we make this table, what is my starting point, my a value? Assumed 1 there. So when I make my table of values, I'm just going to start at 0, put in a 1. So now if we keep going and just keep putting in our values, we're going to keep multiplying by 1/3 our growth factor. So 1 times 1/3 is 1/3 times another 1/3 is 1/9. Now to go in the opposite direction, let's actually plug it in here. 1/3 raised to the -1. So just like we learned in exponent rules, that's really 1/3 to the 1 to the -1, 3 to the -1. Across the line change of sign is 3/1. So actually it's 3. And that kind of makes sense now going forward, because 1/3 times 3 is 1. Anyone want to predict what -2 will be? Yeah, it will actually be 9. And if you don't believe me, you can come over here and write y equals 1/3 to the -2. It's going to make both cross the line change the sign. So 1 to the -2, 3 to the -2, which is just 9/1. So as you can see, the table itself, it's still multiplying by 1/3, 1/3, 1/3, all the way through for my growth factor. But I like to tell kids when we're dealing with fractions, here in this direction, you're multiplying by 1/3, but if you want to go backwards, you're kind of almost like multiplying by 3 in that direction. It's kind of weird, but it works. So if we plot the points here, our first dot will always start at y-intercept, which in this case is our a value of 1. Then we have 1/3, which is like right here. And then 1/9, you can hardly even touch it. And then -1 is where we're getting larger now. And -2, we're getting up to 9, which is way up here. So again, now we're going to draw our smooth curve like this. And that is your first decay model. So that's kind of a pretty cool decay versus growth. So again, what do you think made this a decay? It was that our growth factor was a fraction. So because this was a fraction, it became a decay. Interesting. Let's try another one where we multiply here by our new y-intercept. We're going to multiply the whole thing by 1/3. I'm sorry, by 2. This is our new y-intercept. So the first thing, let's just write down the numbers we got from the first one, 1/3 to the x, which was 9, 3, 1, 1/3, and 1/9. And then I'll graph it like I did before. So -2, 9, -1, 3, 0, 1, 1/3 here, barely touching 1/9, smooth curve. All right, so now I'm going to change colors, and now we're just going to basically multiply all our values by 2. This is actually be 18. So then this would be 2 times 3, which is 6. This will be our new y-intercept at 2. And then we have times 2 here. This will be 2/3. And then times 2, this will be 2/9. Okay? So now when we graph it in red, it kind of does what it did last time. I'm feeling a vertical stretch here. So we go -2, 18. It was way off here. We can't even, gosh, it would probably be somewhere like way up here. I don't even know. But -1/6 is right here. -6. And then 1, 2 here. 0, 2 here. And then 1, 2/3 right there. And then 2, 2/9 down here. So the graph would kind of look like this with my smooth curve going like that. So definitely a difference there. So because the y values for y equals 2 times 1 and 1/3, 1/3 to the x are twice the corresponding y values for 1/3 to the x, the graph again is a vertical stretch. Okay, so just like we learned in last lesson, something happens when you change the y-intercept to a negative number. So can you take a moment and try to graph this for the checkpoint so we can? Anyone want to predict what's going to happen with the negative y-intercept? All right, let's find out. So yeah, if you compare the two, hopefully you got something like this, right? So the -2 one had kind of inversed it or reflected over the x-axis like that. All right. Okay, so if you turn the page to page 40, okay, so in this one where it says classify and write rules for function, so tell whether the graph represents growth or exponential decay, and then write a rule for the function. So first of all, on the count of 3, is it growth or decay? 1, 2, 3. It's decay. All right. So we know already that the the b value is going to be a fraction. The y-intercept, can someone tell me what the y-intercept is for this one? Yeah, it's right here at 5. So we know that a is going to equal to 5. So then it says find the value of b by using the point 1, 1, and a equals 5. All right, so let's kind of think about this. So plug in what we know. We know that our a equals 5, so it's y equals 5. We just really need to figure out our growth factor raised to the x. So if you think about it, what would take us from 5 to 1? What would take us if we were making this into a table? It would be like 0, 5, 0, 5, and then 1, 1. So if you think about it, what would take us from 5 to 1? That's a fraction. What would you multiply for the growth factor? Hopefully we're thinking 1/5. So that would be that function. And then if I think about it this way, I guess they want us to plug in 1, 1. So y equals 1, x equals 1, and then we put 5 here for my a, and then so that would be 1/5. Not too sure yet how that works. So in the end, exponential growth and decay. Growth has a b value that's bigger than 1, and decay has a b value that's between 0 and 1. So that gives you a fraction there. So again, decay goes like that.